Okay, we'll start in about a minute.
Okay, I'll switch on my camera. So is that I have to self-introduce, or is that somebody is introducing me?
Yes, let me introduce you now. Rajesh Garan is an electronics engineer leading research on humanitarian technologies with special emphasis on robotics at HUT Humanitarian Technology Labs, and a professor of ECE at Amrita Vishwa Vidyapithan University. Could you please pronounce the name of your university so that it's correct?
It's Amrita Vishwa Vidyapithan.
Pinta. Okay. He completed his undergrad in engineering at Anna University, Chennai, and his master's and PhD at AVVU. His research includes embedded systems, robotics, semiconductors, and healthcare, and is focused on autonomous robots, vertical climbing robots, and robots for rehabilitation. He also has 7.5 years in industry experience. He worked on VLSI design, ST microelectronics, and in silicon before joining AVVU. He has published over 150 papers and 4 patents. He has received AVVU's highest award of excellence, the IEEE's 2020 Undergraduate Teaching Award, which we just mentioned, and the IEEE Outstanding Branch Counselor Award. Thank you so much for being here, especially in the with these 12.5 hours time visits all the way from India. I guess you're in Chennai, is that correct? Are you in Chennai?
I am in Kerala.
Okay.
Yeah.
Welcome.
Yeah. Thank you, Karen. Thank you very much for this wonderful introduction. And I thank the organizers of TCF for giving me again an opportunity to be part of this wonderful event. So let me start my talk. So the topic is on autonomous wheelchair for the physically challenged. So let us see what is there in store for this topic. Okay, so looking at the problem, so there is quite a lot of people with mobility issues, including stroke patients, spinal cord injury patients, and some of the elders above 65 years, and even some adults have some mobility issues. So if you look at the statistics, there are about 13+ million stroke patients every year, and about 500,000, right, 250 quarter to 500,000 spinal cord injury. Major of this problem is due to the accidents, bike accidents. And there are about 9% of total population with the age 65 and above. And then the statistics also say that about 18.6% of adults have some mobility issues. Right, so we propose autonomous wheelchair. It's like a self-driving car, like we call it a selfie, with a multi-mode control and self-driving powered wheelchair. So it has a very good algorithm which can make the wheelchair navigation totally autonomous, and it also avoids all the obstacles on its path. It's similar to self-driving car, so we create the map of the environment. So we first create this, and then this map is used for the algorithm for further navigation. All right, so we use the LiDAR sensor, which is common in auto navigation. And also we have multi-mode control. We also have a manual mode, a semi-autonomous mode, and a completely autonomous mode. So the entire software framework is built on Robo operating system. So if you look at the technology, the current one, all right, there are in India, majority of the people with mobility issues use mechanical wheelchairs. All right, one of the reasons for that is the cost associated with the powered wheelchairs. Now, if you take at the mechanical wheelchairs, there is no need of any external energy to move the wheelchair. But the person might get tired because of constant moving, because somebody has to spend the energy, right? If it's not external energy, then the person or the user have to spend the energy, right? So powered wheelchair, joystick is the operation mode, right? So most of the powered wheelchairs that I have seen, or some of the, or few of the wheelchairs that I have seen in India, they all come with the joystick, right? So you don't, so you need to spend some effort, right? The joystick control, you need to hold on to the joystick continuously, and you need to spend or put some effort in order to move the joystick. Whereas the self-driving wheelchair, the selfie, you don't need to, the user need not spend any energy on his or her part. All right, and regarding choosing the destination, well, manual wheelchair, it's done manually, and also joystick control done manual. But in the selfie, we have a touch or a voice based. Also navigation, selfie is totally autonomous. IoT enabling is possible in selfie. And regarding the fatigue factor, the user even can perform other activities while the wheelchair is driving, like reading or maybe even drinking something while the wheelchair is in motion. Now, this is the system architecture. All right, so we have divided this into three major blocks. So we have the Android device, which is the control device, where the user can use the app that we had built, the Android app we had built for this navigation. Then there is a control unit. This is the main controller, right, where we have the complex hardware and the ROS, the Robo Operating System platform. So we have various sensors you can see, right, like IMU and encoders, then the LiDAR, right? These are the major sensors that we use in the system. So we have the wireless interface also, two types. We have the Bluetooth for connecting with the Android device, and also we have the Wi-Fi for the connecting with the software development unit, maybe kind of debugging while we were developing this. All right, so this is the ROS platform, the software where we have written the algorithm for this self-driving or auto navigation control. So we have 4 different units. We call hardware interface unit, a laser scan unit, a master control unit, and application interface unit. So all the sensor data, right, reach multiple units in this ROS architecture, and we use the A-star algorithm. Initially we were using, sometimes we were using the Dijkstra's shortest path algorithm also, along with the SLAM and the localization, AMCL for the localization. So this is the app that we had developed. You can see how we start. So this is the home page of the app. Then we need to connect with the Bluetooth. And then we have some menu that appears. And you can see the 3 different modes in which the user can operate the wheelchair. So this one is totally manual control. It's similar to joystick, but touch based. All right, so you have the direction control buttons, all right, forward, backward, left, right, and also there is a stop button. All right, so the user can touch for any of the control, and then the wheelchair takes that particular direction. In the second type of mode control, it's called fixed mode, right? So the diagram you see is the map of the environment. So inside this facility, there are 5 source or destination from which the user can start and end. So A, B, C, D, and E. So the user can start from any of this point and go to any other point. So only fixed navigation. So that means the user can traverse or travel only to these 5 destinations. This might be useful for some users who have a really bad mobility problem. So they keep going to fixed places for some activities. The final one is the completely autonomous. So if the user touch anywhere in this map, the wheelchair can automatically take the user to that particular point. So the user can choose a random location anywhere. The user can touch here or here or here or anywhere. So the user, the wheelchair takes the user to that destination. All right, so some of the salient features which we have already seen, autonomous, completely autonomous. We have multi-mode interface, touch as well as voice. We use the robo operating system framework for the software development. There are LiDAR sensors used for mapping and localization. And it's also used for path planning. Dynamic obstacles can be detected and avoided. We have tested with more than 50 patients and also with about 20 doctors and physiotherapists at the hospital of our university, which is called Amrita Institute of Medical Sciences. And we have tested with about 25 facilities. So you can see one of the lab room here. This is not our lab. Our lab is a humanitarian technology lab. This is a part of the bachelor electronics, basic electronics lab, right? So you can see the wheelchair here, and this is the facility that we have tested, the initial testings, test of the self-driving wheelchair carried out. Right, so you can see the map, right? So I have put here the original lab, so you can relate the map to this. So you can see that there is a bay kind of a area here, a table, a big huge table. So you can see that is this part, right? And then the first one here is this part. And there is another table here, small table. You can see here, this part here. And there is another big table which is not shown, which is not seen in this image. And there is also a door to this lab facility, and there is also a corridor here outside the lab. So this is the map that we use for the quite few of initial testings. So these items here, the table and chair, are called static obstacles, right? Because they are not going to move anytime soon, right? So the selfie takes care of both the static and the dynamic obstacles. So how did we evaluate this? So we have multi-prong approach for the evaluation. This gazebo is associated with the Ros simulator. So the initial tests, software simulation tests were carried in gazebo, and we performed the integrated system testing within our lab, where we test with the real wheelchair. Then we test with some selected volunteers with particular tasks to be performed in a certain amount of time. Then finally, we do the field tests with the patients at the Physical Medicine and Rehabilitation Department of Amrita Institute of Medical Sciences, Kerala, India. Right, so you can see the same room, right, is like for the simulation, we created a similar room in the gazebo, right? So you can see this bay here, and the second bay, there is a table here. The table is shown here clearly in this one, right? So here you can see the destination or source. A source can be a destination itself, all right? Because if you start from one place, say A, you can come back to A again. So it can be a source or a starting point, as well as the end point or destination. So in this example, you can see the wheelchair here, the tiny one, right? So it started from C and it is trying to reach E. So this sample showing the navigation of the self-driving wheelchair from the point C to E. Right. So now we go to the fixed mode tests, right? Because there are the destinations or sources are fixed, right? So in this one, we have 5 destinations or sources, right? And these O1, O2, etc. up to O5 are the obstacles. They are static obstacles, right? So this is a fixed mode test using the Ros visualization. Actually, you can, when the wheelchair is navigating through the lab, you can see actually where in the map the wheelchair is currently. So it is kind of live watching of the wheelchair navigation in the map here. So we have some tests performed, several tests, right? This is one sample test that I have shown here, right? So from A, right, if A is the source, then there are 4 destinations. Similarly, B can be a source, C can be a source, D and E. So there are 20 possible combinations, right? So the obstacles here are dynamic obstacles. So we tested both with and without dynamic obstacles. And the path length from A to B is like 3.71 meters, and A to C, A to D, and A to E. And how much time it took for the wheelchair to start from A and to go to B, A to C, A to D, and A to E. So that is also mentioned. There is a ratio we measure, right? So to find out how well the wheelchair had performed its task. Then we have the speed with which the wheelchair was going on, and also the response time. That is, the response time is when the user gave the command through voice or touch, how much time it took for the wheelchair to respond. So that is the response time. Right. So in auto mode test, right. So we chose 5 volunteers from our research lab, right, and they were asked to start from anywhere in the lab, and they are supposed to select 4 different destinations. Randomly, they can choose. So you can see that there is a blue dot, a star, a triangle, and a black, a diamond, and a square, a red square, and each of them are 5 in number, showing where the user actually started and what all the like 4 different destinations randomly chosen by the user. So we see that 20 sources or destinations in this map, right? So now you see that we have conducted so many tests. I have not included that many tests, right? So this is one such corridor on the ground floor of our university campus. Like it would be like 30 meters approximately in length, and maybe 6 or 7 meters in width. So this is the total corridor here, like you can see here, and we put the wheelchair in loop, all right, and then it goes on continuously for quite some time, all right, and then see whether it is able to reach these fixed destinations. You can see the red spot here are the fixed destination chosen at the corner of this area or this corridor, and the path that was traversed by the wheelchair are shown in the blue color line. So we also carried out the door tests, all right, because that is very, very important. The wheelchair should be able to enter the door and exit the door without the problem, right? Now, for this wheelchair, there are certain restrictions while traversing because it needs some clearance on both the side of the wheelchair, right? That is because of the sensors that is attached to this. That is one requirement, and the door should be of certain width. If the door is narrow, then the selfie cannot enter that. So if we want to use the selfie in a facility, then these requirements are to be met, right? Minimum requirements are there. Otherwise, it will end up in a failure, right? So this is the same lab facility. You can see the first bay alone here. This is the entrance here. So the star is the starting point and the dot is the ending point. So you can see the various ways in which we wanted to reach the ending point, starting from the corridor, right? So, and the percentage of success reaching the point is given below, right? So we can see that in 4 cases, we have 100% success, right? And in 2 cases, we have 80% success, particularly when it is in the when it is taking a kind of a U-turn, right? Here also it's kind of a U-turn, and here is also kind of a U-turn, all right? So it's only 80%, right? And in some cases we see 90% also, but we are quite working to improve this success rate through the doors. Like majority of the doors here at the university, they are not designed for a wheelchair, for this kind of wheelchair entry. Of course, a manual wheelchair can enter, but as I mentioned, selfie requires some clearance on both the sides for properly navigating. So that is one of the requirements, right? So this is the field test, that is the test conducted with with 2 groups of volunteers. In the first group, the wheelchair, the users are given both the joystick and the selfie wheelchair. So we want to do a comparative study. But in the first group, the users are already joystick wheelchair users. So you can see that there are 6 volunteers chosen in the first group, and all of them are using powered wheelchair with joystick control. And some of them have used the joystick control for 6 years, and one of them only 1 year. So on an average, about 3 years, the users in the group 1 have used the powered wheelchair. All right, and then we gave the selfie, all right, and asked them to use the selfie. So after using selfie, we asked them to rate both the wheelchairs, powered wheelchair as well as the joystick control wheelchair and the self-driving wheelchair, in the scale of 5, 5 being the best and 1 being the worst score, right? And you can see that, right, out of the 6 volunteers, right, all of them gave, right, 4 of them have given 5 points and 2 of them 4, right? And they also would prefer to use the self-driving wheelchair, right? And only 1 person, right, said no. The user, that particular volunteer, would use the joystick wheelchair. The reason was that after using for 6 years, the user has a psychological connection with the wheelchair and is not ready for the change. Right, and some of them here, right, 2 of the volunteers, at least 2 of them, have expressed that they kind of forced to use the joystick, even though they feel that they cannot put that much effort in controlling a joystick, but they don't have option because that is the only type of control mechanism available for them. So they were really happy to see the touch-based one and use the selfie. So now we go to the second group of volunteers, 8 of them, who have no experience in using any kind of wheelchair, either joystick or selfie. So it's totally new to them. Both the wheelchairs are new to them. So we gave them both the wheelchairs and asked them to perform similar tasks and again rate after using the wheelchair in the scale of 5, 5 being the best and 1 being the worst. So you can see the scores here. Right, so the selfie has got a very good rating, and out of 8, 7 of them said they would prefer self-driving wheelchair compared to the joystick control wheelchair, and 1 of them could not tell which one that particular volunteer would prefer. Right, so usually what happens is that when we take the wheelchair, right, the wheelchair is not given immediately to the patients to test. So the next kind of test we are looking at is the test at the physical medicine and rehabilitation department of the AIMS hospital, our university hospital. Right, so before we can give the wheelchair to the patients for testing, the doctors and the physiotherapists have to approve. So you can see that 5 of them, the users or the volunteers, including doctors and physiotherapists, so they use the selfie and given the rating here, and all of them are unanimous in approving the wheelchair for testing with the patients. Right, so we go to then choosing the patients. So we have done with several patients, as I mentioned earlier, but in this I have only given the 5 patients with their age, sex, and the health condition. So you can see 2 of them or spinal cord injury patients. So you can very young age, both of them had a bike accident, and when the bike hit something, they they were thrown out of the bike and landed on the hard surface of the road with their neck. So it's like from the neck till their legs, their feet, they are totally like paralyzed. So they are getting therapy at that time in that rehabilitation center. And then there is one stroke patient and also two elders that with which we tested the wheelchair. So here we have asked them given them the questionnaire after after using the wheelchair, right? So the first question is how comfortable they were in providing the destinations using the Android app, and is that the selfie reached the destination, and how much user friendly and how smooth the movement. Initially there were some jerks, it was shaky, but then later we were able to fix that. Then the next question is, this is a very important one, because when we took the wheelchair to the rehabilitation center, it was so busy with so much of activities, with so many physiotherapists moving here and there, with the people, with the nurses bringing the patients for the therapy. Well, there is several kind of therapy arrangements for different kind of treatments that is going on there. So it was so busy, right? Actually, so far till that time, we were testing the wheelchair in a nice, quiet place where there were only known people, known obstacles, even if it's dynamic, right? But that was a challenge for us initially, right? And it also gave us a good knowledge about our algorithm, about our system we implemented, and it was a very happy news at the end, because in spite of all these dynamic obstacles, the selfie could reach the destination, right? So that was one of the questions. And then comfort level, satisfaction level, and then whether they would recommend the selfie to others. Right. So most of these questions, all of them were happy because they got something, right? They feel that they can be independent, right? The major problem with such patients is that they feel that they are like kind of a burden to the caregivers, maybe their relatives or family members or something. So that is the major problem that the doctors or the physiotherapists at the center was telling us. So when they see a wheelchair and when they see that there is a hope that they can be independent, right? They were all really happy, and most of them have given positive feedback for all these questions. Right. So only one question where that the feedback was with still above average, but it was around like 3. The point 3 was whether the wheelchair was smooth. As I mentioned, initially the wheelchair was a little shaky. There was a misalignment in the a small misalignment. It's not that shaky, but still people can feel. So that was the reason that we got a score a little bit above average, but it's still above average score compared to all the other questions, the ratings for all the other questions. Right. So this is the hospital layout. So the patient have to start from the lobby, right, and reach the doctor's cabin, right? So that was the goal. So both the fixed as well as the auto navigation was tested for all the 5 patients. Um, so this is the therapy area, right? Up to this problem, no, up to this area till this part, it's okay because not too much crowded. But being a therapy area, this one with several kind of patients with several different therapy, and the physiotherapist moving here and there, and the nurse bringing in the patients, and then it was all like too many dynamic obstacles. The physiotherapists and the doctors did one test. What they did was about 6 of them, they all like stood in a circle around the wheelchair while it was moving with the patient, and they wanted to know how the wheelchair was behaving, right? So it was quite, because we did not do the test, but we had the algorithm how it should respond, and it responded very well, because if it does not have a path to move, it will stop. So it did as it was designed. So because all the doctors surrounded and the physiotherapist surrounded the wheelchair, there was no space for the wheelchair to move, and it stopped there. Right. So this is testing with some of the patients at the rehabilitation center at the AIMS hospital. So this one stroke patient here. This is the spinal cord injury patient, and this is one elder with some amputation in the feet. All right. So this is testing with the patients. So I think I have reached the end of my presentation. There was one video that I want to show. I think okay. There was a demo video. Let me check. Give me a second, because I think without the demo video, it might not be complete.
Sometimes it's hard to move things over to the screen. It takes a few minutes.
Yeah, just a minute. Sorry about that.
That's okay. It is quite amazing. And I'm just wondering about, later on, I can ask you about the requirements, the regulations regarding doors and so forth. In the United States, there are an enormous number of regulations, OSHA and other ones, that determine the width of doors and so forth. So it might be more predictable in the United States, where there's so much regulation. I imagine there's less regulation in India regarding these structural aspects of buildings.
Yeah, sure. We will discuss. Yeah. So I'm going to share share this video.
I'll let you concentrate.
I don't see the video in my share screen and I try to share. Okay, I have to stop sharing the current one. So, okay, now I'll share my screen. Yeah. Whiteboard.
Well, it certainly is life transforming to have something like this. I have a friend who had a stroke and various relatives who are wheelchair bound. And it certainly changes their lives just to have a wheelchair, let alone if they were to have the opportunity for this, that would be something of a different nature. Be fantastic.
Okay. Do you see my shared screen?
Yes, we do.
The video?
Looks like it's coming up.
Can I just
It
confirm?
it has a person entering a vehicle.
Yeah,
A
yeah,
person.
okay, that's
Yep.
good, yeah. Okay.
Fantastic.
Yeah.
And nowadays,
There he goes. There he's moving.
Is the audio okay?
Yes, it's coming. It was just starting. Yes.
Okay, thank you, yeah.
life's
Very
easier.
good.
But the technology can also be extended to wheelchairs for helping the people with mobility issues. The interest came out after investigating the people who depend on wheelchairs and wheelchair pushers to travel from one place to another in an airport. We realized that people with mobility issues face a lot of difficulties in their day-to-day travel, and most of the times have to depend on a second person. Our self-driving wheelchair, Self-E. Self-E can change the way the society looks into the wheelchairs. Self-E system has 3 phases. In the first phase, the wheelchair is driven through the environment where it has to operate and creates a map of the environment. A similar map is created in the Android application that we developed, where the user can point to the destination that he or she decides to travel to. Once the destination is pointed through the app, Self-E wheelchair lands the shortest path and moves the wheelchair towards the destination. The hardware equipment we use consists of a single laser scanner. This laser scanner can identify the environment and also moving objects like we do. The onboard software automatically reroutes the path while avoiding any sudden obstacles in its path. Our self-driving wheelchair, Selfie, is fully operated using any Android-enabled device like smartphone or a tablet. The users have 3 different modes to operate Selfie: manual, auto, and fixed modes. The manual mode has easy access to the wheelchair with a simple direction interface where the user has to continuously navigate using the app. The fixed mode is used for navigating common places like shops in airports or rooms in hospitals where the destination is known in advance. In auto mode, the user can choose any destination on the provided map. The user has to just point to the desired location using the Android device and the wheelchair starts moving. Self-E can also navigate through tight spaces like passing through doors, corridors, and even getting into a lift. This autonomous technology can be used to deliver goods in industries, food in restaurants, people in airports, hospitals, and grocery shops, etc.
Okay, I think we are at the end. So with that, I conclude my presentation and I'm ready for taking up some questions.
So let's see. I'm interested to hear about the requirements for the doors, and is that, I guess this is something that's evolving over time in the United States. Would it, does it already, it looks narrow enough to go through virtually most doors that are federally regulated.
Okay, yeah. So while you are working in India, you might have seen people here, right, like there are not regulations, right? It's still in that sense, if anybody want to build a facility, right, these regulations are only just coming up, right? Even after like these many years,
Mm,
right? Even now, for example, I'll tell in our university, right? Now we have the um, University of Eminence tag from the government of India, and because of that, right, we need to make sure that these regulations are to be met.
mm, mhm.
If that is the case, now what about the other universities, other colleges, right? It's still not there yet. That's what it's really a sad news, but that is the truth. So people don't have that yet when they build a facility, particularly a common facility accessible by the public. All right. So it's not there yet. But hospitals, now the government has very strict rules. So they have some regulations. But even in hospitals, there are only certain area, certain building. I see that, and it's not that in all the buildings or all the areas, right? When I used to live in US 20 years back, right, even bus had such a facility for the people with mobility issues or who have like wheelchairs. But even today in India, we don't have buses um, that can take in the wheelchairs, right? So that is the situation here. Yeah, it's so hard to be um, uh, with a mobility issue, right? Here, like they really feel bad because um, not much freedom for them.
Well, I know that has made massive changes when the roads are required, has made fantastic changes for people with disabilities when you can go across sidewalks and down across streets without without having to struggle.
Yeah.
So is your market going to be primarily initially in the United States? Or well, you're
Yes.
constantly developing.
It's so currently it's like only indoor, so it's not outdoor yet.
Right.
So it can be in India also. So right. In fact, yesterday we were at the same rehabilitation center testing with two patients.
Mhm.
So one is a patient with who met with the accident, and another one had a stroke. Right. So we can see that like people would want these kind of wheelchairs, right? Because particularly those who are like really have a tough mobility, a very bad mobility, they would want, they would prefer. So it's a quite a good question, right? Marketing in terms of marketing, I would say that US and Europe would be the best because regulation wise, you would see that it would be easy for us. And in India, I think it's going to be really a challenge to market.
I was also thinking that companies that want to promote having people with disabilities work for them could themselves actually purchase such wheelchairs. And if they were doing something like a assemblage operation, this would be an ideal, if the person had mobility in their hands, they could assemble things and design the work environment so that they could be a contributing member of the company. And there probably would be enormous loyalty because they would be having this opportunity.
Exactly. Yeah. So we were when we were doing the marketing study, we found out that the corporate, particularly the companies, they buy because they can afford to buying the electric wheelchairs, they buy and donate to people. So that is one of the avenue for marketing, whether donating to people, right, whether their own staff or not. But we see that quite a good amount of wheelchairs are purchased by these corporates, big corporates, and they donate to people. Yeah, so as a goodwill. So that is one aspect that we have found out. But what you are telling is true. We can look into that direction also, where they can provide to their own staff, and then so that the outcome can be really good, and the staff or the people can be happy at the same time.
Well, there are companies that are particularly interested in improving their image. For example, Amazon, and something like this, if they were able to, they're going to robotics very quickly, moving a lot of the jobs into robotics. But if they could also improve, this could be a great improvement to their image if they were actually helping human beings, not only their bottom line.
Yeah, sure. Yeah, definitely. Yeah.
Now somebody else has the questions. I don't want to dominate this.
Yeah, I have a comment on all of this. A hot area that this topic overlaps and dovetails with nicely is the idea of robotic carts and moving stuff around businesses. And there's quite a lot of buzz in the marketplace on that. And it's kind of the same problem with the doors. What companies need and hospitals need are coordinated automatic doors that open through remote control, just like these other things. And so what you guys are doing is really cool and good. In terms of the companies and their image, I think there's going to be a preponderance of a lot of robotic carts moving all over the place that kind of have the same problem. They have to stop when there's an obstacle. They have to be able to get through doors. I think your navigation thing with the LiDAR is kind of cool, with that thing spinning around to navigate and remapping the area. So I think there's going to be quite a lot of activity in this area. And what I'm seeing today is really beautiful, and I hadn't thought about it before. So bravo.
Thank you. Thank you so much for your observation.
Yeah, enormous difference in quality of life.
Yeah, sure. Yeah, we want to help somebody. So that is the goal. That's why we have the humanitarian technology labs.
Yeah.
So is there any other question?
Any questions at this time? I don't see any in our chat. Let me look one more time.
A thing that these robotic carts do is they park themselves to charge up automatically, so they know where to go back. And I don't know if you guys are at that point yet, or if somebody is plugging this into the wall, the nurse or something.
We are not there yet, so it's not going to automatically charge yet. Somebody has to do that part. But when we are planning to commercialize, so these are the things that we need to take care of, because particularly when we have this self-navigating, similar to the cart you are mentioning, because I had the opportunity to see one of these carts, like when I was in US in 2018 or 17. So ultimately we need to do that, right? Because if it's doing many stuff, it's natural that it should go to the docking station and then charge itself. So commercial point of view, that would be an added advantage.
I guess the life, the number of hours it lasts, is just a function of how big a battery is and how much the thing weighs and all of that sort of good stuff.
Yeah. Yeah, so battery actually, when you compare the cost to the of the wheelchair, the entire system to the battery is not that much costly. So even if it goes bad or it burns out, you can replace the battery. So it's how it works, right? So but quite a good wheelchair, right, has a life expectancy of like 3 to 5 years.
When GPS came out, there was a big effort, a huge industry associated with mapping everything, roads, power lines, telephone poles. And I expect that your industry is going to probably do the same thing for inside buildings. And I suppose it's just that it's infancy now, but I think this will be a big area that people will just take for granted, and from their GPS location, they'll just be able to download the map for that building to their wheelchair or their cart or anything. And it should be quite a lot of work for a lot of people over the next decade or so to get this going.
Yeah.
Great.
Any other question? Anybody has put the question in the chat? I am trying to locate the chat.
Oh, on the top right, well, I'm on an iPad, so it might be different. But there on the top right, there is something that says more. And if you
Okay.
hit more, then you can choose chat.
Yeah.
A lot of messages, private messages, just from one person to another person, but
Okay.
not too many general ones. So
Okay, there is no question in the chat. So if that is the case, then I think we can wind up for the day.
and I want to thank you. I realize now that it would have been good for me to have reached out to some of the hospitals and hospitals and other medical facilities to find and individuals at them to invite them to this talk, because that would have been so inspiring for them. I can see that if you come back again, then we could include those people in our marketing plan, so that that you get that exposure. Not only the IT people. All right, we're very grateful for your coming here, and it's very inspiring.
Sure. I hope I can come again.
Oh, absolutely. I certainly hope so
Yeah.
too. Yeah, it is certainly my first choice.
Yeah.
So,
yeah. So thank you very much. Thank you, Karen. Thank you, the organizers of this TCF for this wonderful program, and then putting this together, and in midst of all the pandemic and other stuff. So you are able to successfully pull through this event this year. So all the best. And again, I thank on behalf of my university, my lab, for this wonderful opportunity. Thank you so much.
thank you for your inspiring talk.
Thank you very much for coming.
Yes.
Thank you. Thank you.
So let's see. So we have we have a break now for a few minutes, and then Nia will be introducing our next speaker, Evan Williams. And so